Alright, so today we're going over implicit differentiation. With implicit differentiation, think of it as like sorting. Let's say we find the derivative in terms of x squared plus y squared equals 100. So for this, if we find it in terms of x, we would have 2x plus 2y dy dx. And we put that dy dx because when we find derivative of y squared in terms of x, essentially, it is 2y multiplied by y prime by the chain rule. But y prime and dy dx are completely the same thing. And equal 100, derivative of 100, because it's a constant, will just be 0. So now is where the sorting factor comes in. You want to have every number with the dy dx, you want to have it on either left or right side. And then every number without the dy dx, you want to have it on the other side. So in this case, we're going to move 2x to the other side. So we'll have 2y dy dx equals negative 2. And now what we want to do is we want to get dy dx by itself. So we divide by 2y on both sides, and we get dy dx is equals to negative x over y, because the 2 cancels out. And some things to remember here: when you find derivative in terms of x, for example, x cubed will turn to 3x squared, and then y cubed will turn to 3y squared multiplied by dy dx, or multiplied by y prime. But let's say you're finding derivative of in terms of y, then the derivative of x cubed would now be 3x squared dx dy. But rarely they'll in an implicit differentiation, you don't really find derivative in terms of y, really. You will do it mostly in terms of x. So these are some things to know. All right, so let's start with number 1 through 4. And for all these, we're finding derivative in terms of x using implicit differentiation. So for number 1, we have 5x squared minus y cubed equals 7. So we're going to write it out using derivative. So if you write it out, we get 10x, derivative of the first thing, and then y cubed, derivative of that is 3y squared dy dx, equals 7, derivative of that is just 0. So now we want to get them both separated. So we have negative 3y2 dy dx equals negative 10x. And now we divide by negative 3y squared on both sides. So we're left with dy dx equals 10 over 10x over 3y squared. And that would be your dy dx for that. And it'll tell you sometimes to find the slope of the tangent line. In that case, grab the x and y value of a point. So let's say they say find the slope at point 0, 3. Then we would plug in 0 for x and then 3 for y, and then that would be our slope. That's why we find the dy dx. So now number 2. Number 2 is 6x to the 4th power plus y 5 equals 2x. So if we do the same thing, we'll have 24x to the 3rd power plus 5y to the 4th power dy dx. And then on the right side, now we actually have a non-constant, so it would be 2, because the x cancels out. Now if we get it all on one side, we get 5y to the 4th power dy dx is equals to negative 24x cubed plus 2. And now we divide by 5y to the 4th power. And so we're left with dy dx is equals to, we could rewrite it as 2 minus 24x cubed over 5y4. So you could kind of see like the pattern here in which why I called it sorting, because you want to sort the dy dx from the other numbers, and then so you could have a better visualization and also divide them so that you can get everything on one side at the end. Now let's move on to number 3. So number 3, we're dealing with some radicals here, but like before, whenever you see a radical, always try to rewrite it as an exponent. So Radical would be exponent of half, so we would get x to the half power plus y to the half power equals 1. If we find the derivative, we get 1 half x to the negative 1 half power, and that would be plus 1 half y to the negative 1 half power, and that would be dy dx is equal to 0 because derivative of 1 is 0. So now if we get everything to one side, we're going to have 1 half y to the negative 1 half power dy dx is equals to negative 1 half x to negative 1 half power. And we're going to rewrite this just because it looks a little bit ugly, just so you know you could see it a lot better. So if we rewrite this, we're going to have 1 over 2 square root of y dy dx is equal to negative 1 over 2 radical x. Now what we do here is let's take out the fractions here by multiplying 2 radical x to this side and then 2 radical y to that side. So if we do that, let me make some space down here. If we do that, we will get 2 radical x, dy dx is equal to negative 2 radical y. And now we just divide by 2 radical x on both sides. So our final answer will be dy dx is equal to, it would be negative 2 radical y over 2 radical x. And the 2, of course, cancels out, so we would have negative radical y over radical x. And that would be your final answer of dy dx. And for number 4, let's free up some space real quick. Alright, for number 4, we're probably going to deal with some negative exponents because, again, I don't like fractions, so I try to rewrite it out. So we're going to have 2x to the negative 1 power minus 1y to the negative 1 power is equal to 4. So we find derivative of that, we would get negative 2x to the negative 2 power minus, or rather actually plus y to the negative 2 power is equal to 0. And oh yeah, I forgot to put a dy dx. So negative 2 dy dx and is equal to 0 because the derivative of 4 is 0. So now we're going to do the same thing. We're just going to get everything on one side. So we have, let's also rewrite the negative exponent. So we're going to have 1 over y squared dy dx is equal to 2 over x squared, just that. And again, we're going to try to get rid of the fraction. So if we cross multiply, really, we're going to have x squared dy dx is equal to 2y squared. And now we're just going to divide by x squared on both sides. So our final answer is going to be dy dx is equal to 2y squared over x squared. And the sorting here is really important, especially when we deal with negative exponents and when we deal with fractions especially, so you don't get confused. But that will be our final answer. Alright, so now we're going to move on to these questions. I've crossed out 2 of them for spatial purposes, and we might not do some others because of space. But let's move on to number 12. So most of these questions here, we're going to deal with trig functions, and we're going to be using the product rule a bit, some chain rule, and no quotient rule, which is awesome. But number 12 is e to the power of x sine times y, sine y equals x plus y. So for the first part here, the derivative of that, we're going to have to use a product rule. So the product rule is f g prime plus f prime g. So now if we find the derivative, we're going to have e to the power of x multiplied by g prime, which is cosine y dy dx, because that's y. So when we find the derivative of sine y, we're going to have to use a dy dx because we're doing it in terms of x. And then we get plus f prime, which is just e of x, times g, which is going to be sine y. And that is going to be equal to 1 because derivative of x is 1, plus 1 dy dx because derivative of y is 1. So we're just going to put dy dx. And this is a bit, a lot to look at. But so this is dy dx. Let's keep dy dx on the left side. So this going to stay here. We're going to have to subtract this to the other side because there's no dy dx. Let's subtract this dy dx to the other side. So we rewrite all of that. We would get ex cosine y dy dx minus 1 dy dx is equal to 1 minus ex sine y. And now we could factor out this dy dx for this. So if we factor that out, we would have ex cosine y minus 1 dy dx. And all we need to do is just divide this on both sides, and now we get dy dx by itself. So if we divide them, our answer would be dy dx is equal to 1 minus e to the power of x sine y over ex cosine y minus 1. And that will be your final answer. And so now number 15, we're going to do 13 later. So we did 12. Number 15 is going to be y cosine x equals x squared plus y squared. So again, we're going to have to use the product rule. So me f g prime times f prime times g. So f is going to be y, g prime is going to be negative sine x plus f prime, which is going to be dy dx multiplied by g, which is going to be cosine x. And that's going to be equal to 2x plus 2y dy dx. And now we want to sort it again, in which we want to get dy dx parts all on one side and then everything else on one side. So let's bring this to the right side and let's bring 2x to the left side. So we rewrite it out, we get y, or negative y sine x minus 2x is equal to, we'll factor out dy dx as well, and that's going to be equal to cosine x plus 2y, and then dy dx on the outside. And now if we divide by cosine x on both sides, cosine x plus 2y on both sides, we would get our answer is dy dx is equal to negative y sine x minus 2x over cosine x plus 2y. And this would be actually positive because we moved a negative to the outside. So when we distribute, the negative would also go to a 2x. So we would have that there and that there. So that would be your answer, dy dx, for number 15. Alright, so now we're going to do number 13. I've cleared the whole screen, so we're going to do number 13 and 16 and try to do either 18 or 19. So number 13 is going to be a case of chain rule because we have sine x plus y in the inside. So if we find the derivative here, if we remember as well, the chain rule is f prime g of x multiplied by g prime. So if we used to find the derivative here of this, we would have cosine x plus y multiplied by the derivative of the inside, which would be 1 multiplied, or rather 1 plus dy dx. Or it could be 1 dy dx as well. So that would be that. And then on the other side, we would have derivative of cosine x is going to be negative sine x. And derivative of cosine y is going to be negative sine y dy dx. So now we're going to do the same thing here. We're going to get the dy dx on one side. But first, we want to multiply this out, distribute it. So we're going to have cosine x plus y plus cosine x plus y dy dx. And now we want to get everything on one side. So let me just finish writing the other side out. Sine y dy dx. Getting a little bit messy. But so let's bring the dy dx to the left side and then everything else to the right side. So we want to bring the sine y dy dx to the left side, and then the cosine x plus y to the left side, or right side actually. So if we do that, we're going to have cosine x plus y plus sine y, and then that's going to be dy dx on the outside equals, and on the right side we're going to have cosine x plus y minus sine x. And now we just divide divide cosine x plus y plus sine y on both sides. And our final answer will be dy dx is equal to cosine x plus y minus sine x over cosine x plus y plus sine y, or sine y actually. And that would be our final dy dx answer. Alright, so now let's try number 16. So number 16 is sine xy equals cosine x plus y. So this is going to be a case of chain rule again, except for left side we're going to use chain and then the product rule. And the right side will just be chain and then the power rule. So for the left side, we have sine xy. Derivative of that is going to be cosine xy. And then that's going to be multiplied by derivative of the inside function xy, which we're going to have to use the product rule, which the product rule is fg prime plus f prime times g. So fg prime is going to be x times dy dx. So we're going to have x dy dx plus f prime, which is 1 times y, which is going to be just y. And that's going to be in a parentheses. And then on the left side, on the right side actually, we have derivative of cosine is negative sine x plus y. Oh, I made a hush of that. And then we have the derivative of the inside function, which is x plus y, which is going to be 1 plus dy dx. And now what we want to do is just multiply out everything, which is going to be a bit of multiplication. So we're going to have x cosine xy dy dx plus y cosine xy. And then on the right side, we're going to have negative sine x plus y plus, or plus negative sine x plus y dy dx. I don't have space to write it there, but dy dx goes to that. So now what we're going to do is get the dy dx on one side. So we're going to take sine x plus y dy dx and put it on the left side, and then y cosine xy put it on the right side. So if we do that, we're going to have dy dx, open parentheses, x cosine xy, and plus sine x plus y, and that's going to be all in the parentheses, dy dx on the outside. And then on the right side, we're going to have y cosine xy minus sine x plus y. And now if we divide if we divide x cosine xy plus sine x plus y on both sides, we would have dy dx is equal to y cosine xy minus sine x plus y over x cosine xy plus sine x plus y. And that would be your final answer. It is a bit long and tedious of answer, but that would be your final answer, dy dx, for number 16. Alright, so I want you guys to try number 5, 7, 9, 10, and 11. So you could pause the video and try those out. Alright, so let's try number 5. Number 5 is x squared minus 4xy plus y squared equals 4. So we rewrite it as a derivative in terms of x using implicit differentiation. We would have 2x minus, and so this is going to be a product rule here, so we're going to do negative 4x multiplied by y. So we find the derivative of product rule again is 5g prime plus f prime g. So we're going to have a big open parenthesis. We're going to have f, which is going to be negative 4x, multiplied by g prime, which is going to be dy dx. And that's going to be added on to f prime, which is going to be negative 4 times y, which is just going to be, just y. And now let's close parentheses. Now we're going to do plus 2y dy dx equals to 0 because 4 is a constant. And now we're going to make this look a little bit better by multiplying everything out. So we have 2x, and in the parentheses here we have negative 4x dy dx plus negative 4y. So we multiply that out, we'll have plus 4x dx dy dx. That would be plus 4y, and then plus 2y dy dx. So what we'll do here is we'll leave the dy dx on the left side, and we'll take the x, 2x, and then 4y to the right side. So if you just subtract by 4y, subtract by 2y, we're going to be left with dy dx 4x plus 2y is equal to negative 2x minus 4y. And then if we divide by 4x plus 2y on both sides, we're going to have dy dx is equals to negative 2x plus 4y, because I distributed out the negative 1, over 4x plus 2y, and that would be your final answer. And now let's get on to number 7. So number 7 is going to be down here. Number 7, we have x to the 4th power plus x squared times y squared plus y cubed equals 5. So we find derivative, we're going to have 4x cubed plus, again, the product rule, which is fg prime plus f prime g, which is going to be plus x squared times 2y dy dx. So we're going to have 2y dy dx, and then that's going to be added on to 2x plus y, 2x times y squared, actually. And then we have y cubed at the end, which is going to be 3y squared dy dx, and equals 0, of course, because 5 is a constant. So here we have 4x cubed x squared 2y dy dx. So this is, we could also use this method in which we draw shapes around it so we know what goes where. So around the dy dx, I'll draw like an oval, and then the non-dy dx will draw a square. So this is a non-dy dx, so we have a square, and then we have an oval around this. So let's move the squares to the other side. So if we move the squares to the other side and keep the circles on the right side, or left side rather, we get dy dx, open parentheses, 2yx squared plus 3y squared is equal to negative 4x3 minus 2xy squared. And now what we're going to do is divide 2yx squared plus 3y squared on both sides. So we do that, we're going to have dy dx. Our final answer is going to be negative 4x cubed plus 2xy squared over 2yx squared. Oh, I kind of put that in the wrong order. Plus 3y squared. And that would be your final dy dx answer. Alright, so now let's move on to number 9. So number 9 here, we're actually going to have to use a quotient rule. And the right side, we can just use the power rule. So the quotient rule, if you remember correctly, it's f prime g minus fg prime over g squared. So this is going to be a bit to work with. So f prime, f is going to be top, g is going to be bottom. So we're going to have f prime is 2x multiplied by g, which is going to be x plus y, minus f, which is going to be x squared, multiplied by g prime, which is going to be 1 plus dy dx. And that's all going to be over g squared, which is going to be x plus y squared. And then we have on the right side, we have 2y dy dx and plus 0, so we just don't write it. So this is quite a bit we're having to deal with here. So what we're going to do is we're going to multiply everything out, and then we're going to see what we're dealing with. So, and also we're going to push this to the right side just so we don't have a fraction. So if we multiply everything out, we'll have 2x squared plus 2xy minus x squared minus x squared dy dx. And that is equal to x plus y. If we multiply that, will be x squared plus 2xy plus y squared. And then multiplied by 2y, we would have 2x squared y plus 4xy squared plus 2y to the third power. And all of this is dy dx. And now what we want to do is separate the dy dx from everything else, which the only dy dx here we have is x squared, or negative x squared rather. So we want to move this to the right side. So if we rewrite it out, we'll have 2x squared plus 2xy minus x squared, and then equals, we'll have 2x squared plus 4xy squared plus 2y cubed, dy dx, and that's going to be plus x2 dy dx, but we could also add x2 inside there. Now if we divide both sides by 2x squared plus 4x squared plus 2x cubed plus x2, it's a lot to process here. At the end, we're going to have dy dx is equals to 2x squared plus 2xy minus x squared over whatever's on the right side that we moved, which is going to be 2x squared plus 4x squared plus 2y cubed and plus x squared. And even though it's very long, that's going to be our final answer for the derivative using implicit differentiation of number 9. Number 9 is a good example of how the problem can get very long, but organization is key, so you know what goes where, and sorting both from the left and right side of dy dx is very important. So let's move on to number 11. So for number 11, we're actually we're gonna skip number 10 just because we've dealt with that type of question already. So number 11 is gonna be pretty straightforward, I think. So derivative of sine x is gonna be cosine x in terms of x, and then derivative of cosine y is gonna be negative sine y. That's gonna be dy dx because it is a y function or y equation. And then on the right side, we have 2x derivative of that is 2 minus 3y derivative of that is going to be 3 dy dx. So now we want to get all of them on one side. So let's bring negative 3 dy dx to the left side and cosine x to the right side. So if we do that, we're going to have dy dx. I always like to factor it out because it just, I factor out dy dx because it makes everything look just so much better. There are 3 minus sine y. And on the right side, we're going to have 2 minus cosine x. And now we just divide by 3 minus sine y on both sides. So our final answer is going to be dy dx is equal to 2 minus cosine x over 3 minus sine y. And that would be your final answer for number 11. Alright, so I want you guys to try number 26. So for number 26, we're actually going to be finding the derivative in terms of y. So basically think of what you did earlier except exactly the opposite. So when you find the derivative of x, it would be dx dy. So we're going to use dx dy here. We're going to find out what that is equal to. So you could pause the video and try that out. So let's take a look at number 26. Number 26 is y times secant x is equal to x times tan y. So we're going to have to use the product rule here, which is fg prime plus f prime g. So we use the product rule. We're going to have f, which is going to be y, times g prime, which is going to be actually a pretty long answer. Secant x times tangent tan x. And that's going to be dx dy because we just found derivative of x. And this answer should be in terms of y. So we're going to have dx dy instead of dy dx. And now that's going to be added on to f prime, which is just 1 multiplied by g, which is just going to be secant x. And that's going to be equal to, we're going to have to go down a row actually, because we're not going to have space. So f, which is going to be x times g prime, which is tan y, derivative of that is secant squared y, and plus f prime, which is going to be dx dy, multiplied by g, which is just going to be tan y. And now it is a bit to look at, but we're going to actually get all the dx dy on one side and then the rest on one side. So let's square out the variables here. So we have y secant x, which is going to be a square because it's not a dx dy. And then, oh, actually this, the tangent at dx dy is actually with this, so. Okay, so we're going to draw the rectangles over the dx dy actually, and the ovals over the non-dy dx dy. So this can be an oval, and then x secant squared y is going to be an oval, and then this is going to be a rectangle. So what we're going to do is we're going to bring this rectangle on the right side to the left side, and this secant x squared oval to the right side. This to the left side, not the right side. So now if we rewrite it as a, to look a lot better, we're going to have y secant x tan x dx dy, and that's going to be added on to tan y dx dy is equal to x secant squared y minus secant x. Now you did see I didn't put parentheses around the trig function variables. I'm a bit lazy, but so you see we have all the dy dx dx dy rather on the left side, and this time I didn't factor it out, but you could also visualize what it would look like if I did factor it out. So what we're gonna do is divide on the left side y secant x tan x and minus tan y. So if we do that, our final answer will be dx dy is equal to what numerator, which is x secant squared y minus secant x over everything on the left side that wasn't dx dy, which is going to be y secant x tan x minus tan y. And that is our final answer. You could also put parentheses around the x and y variable just to make it look a lot better. But that is going to be our final answer, dx dy for number 26. Alright, so basically, that's essentially implicit differentiation, and the most important thing that I would suggest to understand is knowing how to sort the dx dy or the dy dx from the other stuff in the equation, so that you can create a very organized answer, and then you know the process of getting your answer as well, and knowing what to do when the question asks you to find derivative in terms of x and then find the derivative in terms of y, but most times it will just be find the derivative in terms of x. Rarely you're going to have to find it in terms of y. So when you find it in terms of x, you're always going to have to do dy dx when you find the derivative of something with a y variable. And you always got to remember, sometimes you'll use the chain rule, especially for trig functions, but you're going to have to use the product or the quotient rule, or even just a power rule included with that chain rule. But it is a lot of space take up. It takes more space up than actually quotient a product rule. But as long as you stay organized, your answer will probably not deviate from the wrong from the right answer rather. But yeah, that's basically it.